In this video, we're going to look at a common novice programming mistake in Java, and that's the use of the equals operator instead of the equals method when comparing strings. In fact, this is a common programming mistake even by experienced Java programmers. One of the reasons for this is it can be quite difficult to detect by ordinary testing, so we need to be very thoughtful when we're coding string comparisons. Here's a typical example of the error. We want to compare two string objects to find out whether the string referred to by name is Snow White, and it's quite natural to think that using the equality operator will perform that for us, whereas in fact we should be calling the equals method on the name object in order to make the comparison. Here's an example of the problem within a context, a coding context. We've got iteration over a collection, and we're looking to find whether a particular student object has a name that matches the string parameter. And we're incorrectly using the equality operator to make the comparison. If we find the student, then we want to print out their details, but if we don't find them, then we print an error message saying the student is not in the class. So let's take a look at this code within a program and see why it can actually be quite difficult to realize that this is an error. Here we've got a program. Here's the source code that we've just been looking at, and there's the incorrect comparison. I've set things up so that we've already got a class of students. We can print out the list and see who's in the class. We have 3 students: Snow White, Lisa Simpson, and Charlie Brown. So I'm going to search for Snow White. Let's call the find student method, look for Snow White, and we can see over here that we find Snow White, and the method actually returns the result true to say that Snow White is in the class. So that appears to work okay. Let's search for a student who's not in the class. Let's search for Spider-Man, and the method returns the value false to say Spider-Man's not in the class, and that's printed out. Now, I've actually formalized those two tests within this test class here. I have a method here called test positive find student. We expect to find Snow White, and we print a message and then call find student. We don't expect to find Spider-Man. We print a message and then call find student. And this assert true says we expect find student to return the value true because the student is found. This assert false says we expect find student to return false to say that Spider-Man was not found. So let's see those two in practice. Test positive find student, we find Snow White and the test succeeded. Let's try the negative one. Again, we don't find Spider-Man, and again the test succeeded because we failed to find Spider-Man as expected. I've got a couple of other tests inside this test class that actually expose the fact that our coding is incorrect. Here's a method called test interactive, which prompts the user to input a name to be searched in the list. So find who, we read a name, and then go and call find student. And here's a slightly different version which will also expose the problem. Here we have Snow White embedded in the code, but at runtime we're creating a new string object that copies the contents of this string literal into a new object that's created at runtime. And that's really critical for our understanding of what the problem is going to be. And then we go and try and find Snow White, and we expect, as before, that find student is going to return true because we know that Snow White is in the list. So let's call those two test methods to expose the fact that our current coding of the find method is incorrect. It's unreliable as a way of finding out whether a particular student is in the list or not. So we call test interactive, and we want to find Snow White. And Snow White is not in the class. We've failed to find Snow White, even though previously we found Snow White. We know that that name exists as part of a student. Let's try the other version, which was test use of equals. And this time the test fails. So again it says Snow White is not in the class. So what's the problem here? Why is our coding of find student that uses the equality operator failing to find the student in those two cases where firstly we read the text interactively and secondly we created a copy of the string at runtime in a separate object? To understand the problem, we need an appreciation of the two types of equality that can exist in an object-oriented language. We have what's called reference equality and we have content equality. Let's think about the differences between those two. Suppose we've got two object variables x and y. If x and y are actually referring to the same single object, then we say that x and y have reference equality. If x and y are referring to different objects, but the contents of those objects are identical, then we say that x and y have content equality. And now here's the key point for our example. The equals operator is only appropriate for testing reference equality. That is, do the two variables or do the two references refer to a single object? In the case of the equals method, then we're looking for content equality. Do those two references refer to objects with the same contents? Now clearly, if two variables refer to a single object, they have both reference equality and content equality. But two objects might have content equality, but not reference equality. And actually that's the more common kind of equality that we're interested in. So by using the equals operator in our example, we're only testing for reference equality. So here's an illustration of the difference between reference equality and content equality. We've got two variables, this name and that name. They clearly refer to different objects, even though the contents of those objects are the same. So if we were to use the equals operator, then we would get the result false. Those two variables refer to different objects. But if we were to call the equals method, then we would get true because those two objects have the same contents. And that's essentially what we want in all cases when we're comparing strings for equality. We don't want reference equality, we want content equality. So why does the equals operator appear sometimes to work, but at other times to fail? And to understand that, we need to understand a little bit about what the compiler does before our program runs. So string literal objects in Java source code receive special treatment from the compiler. As a space-saving message, what the compiler does is it looks for identical string literals and then merges those string literals that are the same into a single string object and rewrites the references to those apparently different string objects into that merged single string object. And a key thing to note here is that merging takes place across different source files. So here's an illustration of what the compiler does. Suppose we've defined two variables in our source code referring to two string literals, both of which are Snow White. The compiler will spot that those two literal strings are identical and try and save space by merging them into a common string object containing the common text and then making sure that those two variables refer to that shared object. So it's turned what was non-reference equality into reference equality. The problem is that, of course, the compiler can only do this with compile time literals. So if you're making a comparison between variables that were referring to compile time literals, reference equality is going to work, but any string objects that arise as a result of runtime creation of objects will fail the reference equality test because the compiler couldn't possibly merge those identical string literals with others that it might find in the execution of the program. So reference equality is no longer a reliable test between strings for equality, and so we should avoid using it with strings. This is the correct way to compare strings in a program in pretty well all cases. So instead of using the equals operator, now we're calling the equals method on one of those string objects, and it doesn't matter which one we call it on. So here we're asking the name object whether it has content equality with the string that's stored inside the student object. Let's look at that in practice within the source code. We rewrite that test to use the equals method, compile the code, and now we can run our tests again. We can do positive find student, and that works as before. We can find negative test of student, that works as before. But now the crunch comes, what about the interactive case? If we search for Snow White, are we going to find Snow White? And the answer is yes, we do find Snow White. We've succeeded now with content equality, whereas we failed before with reference equality. Let's just test that the negative case as well. If we search for a student who's not in the list, and indeed we find that's the case. And then the final one was where we dynamically create a copy of the Snow White string at runtime, and indeed we find that Snow White is in the list. So as concluding advice, we should never use the equals operator to make comparisons between string objects when we want to ask, is the text within these two string objects identical? Instead, we should always use the equals operator invoked on one of those string objects to make the comparison. Furthermore, when we're testing our code to make sure that we've followed this rule, we should always test with string literals that the compiler is not able to get access to at compile time. So we can do things like interactive testing, where we read the text from either the keyboard or from a file. And we can also put tests in our code where we dynamically create string objects in the way that we did in the test class.